Okay, so this is part 3 of like a tutorial how to make something like a spaceship shooter in FLAX Engine, or like a helicopter simulator or something like that. And what we got now is that let's see, let's just lower the resolution here so the recording is a bit faster, and so I guess less processing power involved. So we have the last time stuff we had this sort of like simple fly around gunship or something like spaceship. You can say we can do like this, but these sort of like pillars or columns are like persistent and you can't really make them go away. So I've added something like these cubes, and they have a health system. So when they've been hit by 32 bullets, they disappear, or in a sense they despawn, or they're in FLAX Engine it's called destroyed, or they have like a destroy algorithm that something like despawns them from the level. And you can see what happens here now when the bullets disappear here on the right. Notice that that they are here in as it were in the scene. And when you press play, they're removed entirely from the scene tree, if that makes sense. So there is so you can basically see that they are despawned and removed. Try and notice that the crate prefabs disappear, and now the bullets disappear within 4 seconds. Now there's only 2 left, and there was like 4. You would say they are something like they are the green letters in the scene view or the scene tab. So now if we shoot here, and you can see the green bullets are appearing in the scene tab. Another one of some like crates, you could say it's like removed from like the video game, and it's not being rendered or taking resources, and the code and the script that's attached to it is sort of gone, and so in a sense you save on something like code and so on when you despawn stuff, instead of like just making things disappear like visually. So the way that this has been done is, and we talked about it in the last video, you really want to create something like prefabs, because prefabs are much easier to like work with from code. And here's like a prefab of like the crate, and you can see that it has attached a script to it, and then it has I have added something like a box health. Let's see, I'm gonna have to check again. So, and it's basically this script here, and let's see, have I spelled this wrong? Box health. So how does this work? And the first thing you want to do is you want to get something like the box here that's called onStart, because there's a function you need to connect. It's the one called onCollisionEnter, and you will be able to like see it here when you add it, and it's called bind collision enter. And I think these bind boxes are known somehow create like a new function, or you bind a function within the enemy within the engine. But here let's see, the way that I find it is I search for rigid body, and then there's here bind collision enter when a collision happens, or something like trigger enter, and right here collision exit when something like ends colliding with something. So you start by getting this box here, and what happens when you you notice that there is, when you created a plus sign here, and you need to create this. So I'll zoom out so you can like try and like see what happens when you do that. When you click here, it sort of creates a box here, and notice now there is a function here called onCollisionEnter1, and that it says onCollisionEnter1 here. So when you click that plus, you click something that something like it gets added here as like a function. So this here is basically a function. So let's try and like explain what happens here. But the first thing is to like connect all of this. It is that this here collision, it needs like an instance, and in a sense I want it to be the self, or the box itself, or the rigid body that the prefab is built around. So to get that, to make sure that, for instance, if I attached, for instance, I could like take, for instance, this particular box here, and move this in and say I want it to be this, right? But then if I attach the script to something like other cubes, there's like 4 cubes here, it still just sort of like subtract health from this box only, because it's referenced to one specific box, for instance, one specifically named box. So that isn't gonna work. And what we want instead is that we want it to something like find the self. and that is like a little bit tricky. But you search in nodes for self, and then there's something called tools or this instance, and you can read what it does here. It says gets the reference to the script object instance itself. So it basically finds the script, and what you notice here is that the script in the scene, when the screen is, as it were, in the scene somewhere, it's connected to the prefab, right? So so the script, for it to like run in the scene, it has to be attached to something here, or it sort of usually doesn't run. So this script doesn't exist in isolation. It's like connected to this here rigid body that you can I can explain in another video what a rigid body is. But you just sort of like click here, physics, and then there's a rigid body here that you just add, and you sort of like start building stuff like this, a prefab. I've talked about this in the previous video. So so notice that in a sense this script is connected to something, and we can find that something. Let's see here, when we have where was it, here. So we just search for self, and then it says tools, this instance, and now you get this instance, and it's the script. But the script is attached to something, and we can get the actor that it's connected to by searching for actor. Script get actor that is connected to the script, and in this case it's the rigid body, and that's sort of like the what we need to connect when we get the what is it? I search for rigid body here. Oops. Why can't I search rigid? So when we search for rigid body and we get this bind collision enter, we get this. Notice that it needs an instance, and this here is an actor, but it's sort of like and this here needs a rigid body. But in this case, the actor is a rigid body, and it just needs something like a conversion node to something like connect correctly. And then it's sort of like when you connect this, it just sort of like creates this automatically, and in a sense, it's sort of like it just sort of like changes to something like so same as there's a PNG and a JPEG file, a different BMP or bitmap image files. It sort of changes it from sort of like an actor type to something like a rigid body type, and it just sort of like happens automatically when you try and connect this to this instance here. Then you get this box for free, and now it works. So so that's how this here has been put together. And then when we click plus, we get this box here, which is also added here to the list of functions when that happens. And this only happens in the start. This bind collision enter has to like be connected at the start, or you'll keep creating functions non-stop, and that will mess with the engine. This is just something that's supposed to happen the first frame. You build this sort of like function once with this block of code, and then it's there. And in a sense, whenever there is a collision, or whenever something hits the box here, for instance one of the bullets, it sort of like shoots something like this code here. As you can say, this code starts running here. So all I do here is that basically when something hits, I take the current health, I subtract 1, and then I sort of like set that as the new health this frame. So if something hits the box, this frame, I subtract 1 from its health for like I think something like each collision. But something like if there is a hit on something like any given frame, it will take down 1 value from the 32 health points. So it's just sort of like after I have created something like health over here, and I want it to be an integer, or just something like 1, 2, 3, 4, 5, so like sort of like a clean, or like a whole number, and you just add this. And for instance, you can set this to 100 if you want it to be 100 health, 50 if you want it to be 50 health, and then you just sort of like rename it to something like something that you want it to be called. And then something like you can I'm just going to delete this, but that's what I've done here, and I called it box health. So now you wanna, if you wanna like set or get, so in a sense getting this health here is quite easy, but if you wanna set it, you need to right click and you need to write search parameter, and that will give you event key and then parameters. You want the one here called parameters, like parameters set parameter, this one, not the event key. And then you click here, and now you get this box, and you can click down here and see that what you have added in terms of parameters over here, you can sort of like pick here. So you just pick that here, and now you can basically get the health value, this frame, take one away, and then set it if there is a hit on the box. So every time there is a hit on the box, it loses one health. And it sort of like subtracts one whole number from this until it then reaches 0. But that's sort of like another some later code. So that's basically what happens here. But in order to like make it a bit more specific, because for instance, when we start the video game, the box might be a little bit above the ground, and it will like hit the ground, and that hit will like subtract one health if we just subtract a health every time there's a hit. So we want to make sure that it's when there's a hit from the bullets and nothing else, and this sort of like code here does that. So the way it works is that when you create this sort of like on collision enter box by clicking the plus here on this bind collision that you find in rigid body, then you get this, and there's something called obj on object here, and when you hover over it, you can see that it's a collision. There's something like it creates a collision. So what you do is you sort of like move that down here, and then you write unpack. Let's see, oops, here. Why doesn't this work? I think that it says context sensitive, so we write unpack. And then you get this collision, unpack collision. And you can connect it that way, but you can also just search for collision, and then you will get these here, and then it will say pack collision or unpack collision. So you can like find this box in several ways, but it's usually easier to just like move this out and then write unpack, and then you'll sort of like find it. It's sort of like easier to like find the boxes you need. So this here is what's called a physics collider actor. And if you somehow print this, it will be in that format again. It's like, is it a PNG? Is it a JPEG? Is it a bitmap? What kind of like file is it? And we want to change it into a string. So what you do is you just move this out, and you get this, and then you search for string. Let's see here. Just search for string, and you'll notice that in tools there's something called toString. So we basically take this simple like file format and change it into like a text file or text or a string. And now we can use this box here to check, we search for string, or let's see how contains. We need to scroll down, and there's something called string here, and there's like 4 different ones, and some of them don't work. Let's see here, so let's just see if we can like get all of them. Contains, so just be aware that not all of these are the same. So the first one looks like this. You can see it's sort of like not the same as this box I have here, and we can like keep searching. So you need to find the right one. String. Let's see here. Yeah, it's all like let's see here, because it some like changes the order of these sometimes when you search. So let's just see here. For instance, notice that some of the boxes aren't the same, and you want to keep searching until you find the one that has these 2 purple here, and where you can write value here. And in order to remove the white arrows, if you don't want to, in a sense, connect it to the white arrows to run the code, you can right-click on this node and convert to pure node. And that's how I got this node. And now I want to search for something that, suppose that this box collides with something, and it collides with the floor, then it will say, something like, it will say, hit detected with floor. And if there is a connection with a bullet, it will say hit detected with a bullet. So what I did was that I went into this Solid script here, and I named the in a sense the collision. This what connects or hits is the collision shape. In this case, it's the square collision shape. And then I renamed it to bullet type 1 collider. And then I just make sure that not just when a collision happens, but if it's a collision that has this name in it when it's been converted to a string, bullet type 1, so that it's when the bullets or the colliders that are attached to the bullets hit, and nothing else is going to subtract health from these cubes. Even if it hits the floor and like starts flying around or falling off an edge and down and hits the floor, it's only the bullets that will count as collisions. So if it is true that that a collision has happened, and when a collision happens, it will try and fire this, and the collision somewhere in the other actor or the stuff that hits it contains the name of the bullets, so I know that it's one of the bullets that has hit, then I said that if that is true, subtract 1 health. So I don't know if that makes sense. It's sort of like perhaps a bit difficult to keep up with, but if the collision unpacked says that the other actor or what has hit the boxes turned into a string is the name or contains the name of in instance the colliders of the bullets, if that's true, take away 1 health. So that's sort of like let's see, cancel. I'm just gonna delete this here. So that's the basis of like how this works. That we check just to make sure after a collision happens that it's also specifically the bullets and nothing else. For instance, when we push these cubes back, they hit the wall. I don't know if you can see that, but that we start let's see here. That it's sort of like it will inch and sort of like ultimately hit the wall, but I only want the bullets to take away health. So that's sort of like why that happens. Now the last thing is, once we have done this, on start we sort of like connect this bind collision into just once, because if we connect it here, for instance, it will keep sort of like creating this function and somehow create errors. We just want the first frame once to create, or like once when the video game starts or you start playing, that it just creates this function once, and then it's good enough, then it's there, and then after that this box will check for collisions and sort of like specifically from the bullets, and when it's a collision with that's also from a bullet, remove 1 health from the cubes or from this number that's attached to them. Right? So the last thing that I've done here is that we want to check if the health of the box is 0, and if the health of the box is 0, we want to, in a sense, destroy it or remove it so that it sort of dies, quotation marks, when we hit 0. And what happens here is that on fixed update, that runs every frame. For instance, if the game runs at 60 frames per second, then this checks like this runs 60 times every second, so it non-stop checks what is the health of the box. So here it says if and we just get the health of the box this way, and then we get a less than, so we just search for less than, and it should be under comparisons. There's one called less than or less than equal, and we get the box here. Now we have a box that says that if the health is less than or equal to 0, or in a sense the 32 health points here go down to 0, then if that's true on any given frame, we destroy the box. And again, we could try and, in a sense, what box is it supposed to be, because this box here needs an instance, and you find it by just searching let's see destroy, and there is something called object destroy, and then you get this box, but it needs an object or what it's supposed to destroy. So we need, in a sense, something like this, where we take something here and then we move this in. But suppose that we use this, then the box that it gets destroyed every time something like hits health goes from 32 to 0 is a specific box, and we want it to be the box that the script is connected to, or the specific box that's being shot at. So this, in a sense, could be connected here, but it did not work. It only destroy one of the 4 boxes. Let's see. It had only destroyed this here, and when you shot at these other 3 boxes, they did not disappear. It had just forced something like the video game to try and like destroy this box over and over and over. So we need something like to find what object somehow is being hit, or what object somehow we find a way of connecting the objects that being shot at. And the only way of doing that, from what I know, is you search for self tools, and then you get this instance. Gets reference to the script object instance parenthesis self. So whatever is being shot at, or the self. And again, I don't know, sure we can like add this here, and you can like see we can basically connect this script, but it will only destroy, as it were, the script, or perhaps remove the script. So again, once let's see here, once we have this, we don't want it to connect this way. We want to, in a sense, find the actor that's connected with this particular script or object. So we just move here, and then we search for actor, script, and we want to find the actor that the script is connected to. And if you remember that we had this here, we have our prefab, then the prefab, whenever that is put in the scene, has a script on it that's connected to here create this rigid body here. But this box here, this destroy box here just needs like an object, not specifically a rigid body, so you can connect it directly. But that's how you something like draw, instead of like just in a sense destroying one specific box, even if you hit all the others, you make sure that it is the self or the specific script and the object, so on, and the code, and that the specific collision and script and object, sort of like it's this, you sort of like take health away the right way or correctly. So then you can just basically connect this here, and then it sort of like works. And that's how simple it is to like set this up. And then notice that now that I have like a system where, suppose I want like to add more of these sort of like destructible crates, I can just sort of like move them in. And let's just see here what happens. So now we're gonna this is probably in the wall, so that might also like cause a collision. But now we're just gonna add some more cubes, and in a sense, what should happen is that we can just sort of like move this prefab in over and over, and it should just sort of like work. So we can like just move stuff in that somehow gets destroyed when we hit it, and only that. So you see, this is sort of like why it's important that you get this sort of like self. So it's sort of like it's specifically the collision or the health of something like the individual boxes that goes down, so that you can like for instance see here, if we start shooting here, this will lose health, then this will lose health, but they will still sort of like stay here. And if we shoot here, it will basically only get rid of this box, and then we can go back to getting rid of this box. And this can be used for something like creating obstacles or puzzles, or you can give enemies or stuff that move around, something like a health system. So this is quite useful. I'm just gonna delete these, and to give you an idea how you create something like a health system. And you should again try and use prefabs, because whenever you have a prefab, then the script is connected here, and whenever you use the prefab, the sort of like script gets attached automatically, or it's something like already connected to the object, so that this sort of like self-reference works, and you can somehow create this sort of like health system this way. So that's it, and that's it. Yeah, thank you. Bye.